Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it. This one question lost more marks than any other on last year's AQA paper, and it's actually easy if you know the trick. Students wrote down the rounded lengths and treated them as exact. Result, lost method marks, lost confidence, and a lot of wasted revision time.
I remember that feeling. You see 2.3 and think that's the answer, not a clue about what the actual measurement might be.
Exactly. In the next 10 minutes, I'll explain what upper and lower bounds really mean. We'll walk through a worked example, area of a rectangle with lengths rounded to 1 decimal place. Then I'll map each step to the mark scheme and finish with a 10-second quick win you can use in practice papers. Let's work through this step by step.
First, the definition. If a length is given as 2.3 and it's rounded to 1 decimal place, the true value could be a bit smaller or a bit larger. The lower bound is 2.25 and the upper bound is 2.35. We usually write that as 2.25 less than or equal to x less than 2.35. Why that shape of inequality? Because 2.25 would round up to 2.3, and anything from 2.3 up to but not including 2.35 would still round to 2.3. The upper is exclusive.
So the midpoint, 2.3, is actually just the rounded value, not the real measurement. That feels obvious now, but in an exam I can see myself forgetting the exclusive upper part.
Good point. Let that sink in. For 1 decimal place, the step is 0.1, so the half step is 0.05. Lower bound equals given value minus 0.05. Upper bound equals given value plus 0.05. For 2 decimal places, you'd use 0.005. Always think half the rounding unit.
Now a concrete example. A rectangle has length 2.3 meters and width 4.7 meters, each given to 1 decimal place. We want the bounds on the area. First, find bounds for each side. Length 2.3 gives 2.25 less than or equal to L less than or equal to 2.35. Width 4.7 gives 4.65 less than or equal to W less than or equal to 4.75. Write those down. Examiners want to see that step.
Okay, then do we just multiply the lower bounds for the smallest area and the upper bounds for the biggest area? Yes, because both measurements are positive. The smallest possible area comes from the smallest length times the smallest width, so A min equals 2.25 times 4.65. The largest area comes from the largest length times the largest width, so A max equals 2.35 times 4.75. Let's do the arithmetic. 2.25 times 4.65 equals 10.4625. 2.35 times 4.75 equals 11.1625. So we can say 10.4625 less than or equal to A less than or equal to 11.1625. Note the inequality. The upper bound is still exclusive because one or both sides had exclusive upper bounds. This is the exact bounds for area. Don't round these until the question tells you to, and always show the reasoning.
A tiny notation error like writing less than on the top end could lose marks then?
Yes, small notation mistakes are surprisingly expensive. Exam markers look for clear intent, which brings us to the exam technique. Write the bounds, show the multiplication using the bounds, and copy the final inequality. Even if you don't finish the arithmetic, showing the correct method often earns method marks. Here's where the marks typically are. Listen carefully.
Mark breakdown on this kind of question. Imagine it's worth 4 marks. M1, correctly find lower and upper bounds for each measurement. M1, set up the expression for A min and A max using those bounds. M1, carry out the multiplication or show how you'd get the numbers.
A1, give the final inequality and a numerical upper and lower bound with correct inclusive-exclusive signs. Write it down, don't just think it.
So if I run out of time after finding the bounds, I can still get a mark for the method.
Exactly. Marks are there for the taking. Even partial working secures M marks. Common examiner traps, forgetting to take half the rounding unit, using plus or minus 0.1 for 1 dp instead of plus or minus 0.05, leaving out the inequality signs, or writing ambiguous interval notation like 2.25 to 2.35 without stating whether endpoints are inclusive. Be explicit.
Right. Now the quick win. 2 parts. A 10-second midpoint check and a tidy annotation habit you should always use. Midpoint check. Multiply the rounded values. 2.3 times 4.7 equals 10.81. That number should sit between your lower and upper area bounds. If it doesn't, you've likely got an arithmetic slip or the wrong endpoints. Quick and tells you if your bounds are plausible. That's brilliant. It's like a quick reality check that only takes a few seconds. The annotation habit. Always label your bounds clearly. For example, L less than 2.25, less than 2.35, and W less than 4.65, less than 4.75. Then write A min equals 2.25 times 4.65 and A max equals 2.35 times 4.75. Finish with 10.4625 less than A less than 11.1625. That sequence shows the examiner you intended bounds from the start. Even messy arithmetic won't hide the method. Don't skip the check.
I can already see my notes getting neater, and if I have to, I can box the final inequality so it's obvious to the marker.
Exactly. Box it or underline it. Marks are rewarded by people. Make their job easy. That's your quick win for today. Midpoint check plus tidy annotations. 10 seconds in total, but worth marks every time.
Before we close, a short recap in one sentence. When numbers are rounded, always use half the rounding unit to make lower and upper bounds. Show the bounds clearly. Multiply extremes for min and max area with correct inclusive-exclusive signs, and use the midpoint check to catch mistakes.
If this helped, share it with a friend who's revising. You'll find more worked solutions, practice questions, and a printable bounds checklist at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.